Yes, in our last lecture we were discussing about the basic strength, basic nature of amines, which is the most important chemical property of amines, just like basic nature of ammonia. Fine. Now today we'll continue the same topic, that is basic character. It is very important from examination point of view, because in reasoning questions so many questions are asked in the comparison of basic strength with ammonia, amines, and within amines, within aliphatic as well as aromatic amines, right? So let's continue the last topic. See here, both aromatic as well as aliphatic. Yesterday we have taken example of aliphatic amines, they are salts with acids. Today I have taken some aromatic amine. See, this is, you all know, aniline. Lone pair present or nitrogen, it reacts with an acid. Proton is accepted by aniline, results into the formation of anilinium ion. This is called anilinium ion. Fine. So if Cl negative is present along with this, so it will be called anilinium chloride. Fine. So IUPAC naming of such ion is also asked in CBSE exams. Now the another important compound we have here, this is N,N-dimethyl aniline. This is N,N-dimethyl aniline, reacts with acetic acid. So again one proton is accepted, so it becomes positively charged, and acetate ion is present, so this salt is there. This salt is named as N,N-dimethyl anilinium acetate. Fine. So once its IUPAC naming has been asked in exam. Now let's continue further. This reaction represents the basic nature of any amine present in the aqueous medium. So we know basic hydrogen, one proton is gained from water, it changes into this ion, release of hydroxyl ion we have also discussed. Let's write the equilibrium constant for this reaction. If water is taken in excess, it is present in excess, so its concentration is omitted from the expression. So we have written only, this is this ion, OH negative ion from the product side, and from the reactant side it is the amine. Fine. So this expression gives you the value of basicity constant or equilibrium constant for this reaction. And we know if the value of Kb is higher, that means the concentration of product is higher. More the concentration of product can only be there if its basic nature is more. That means it have higher tendency to accept protons. Fine. So I have mentioned here, higher the value of Kb, higher is the basic strength of the given amine. Fine. Now there is another term which is used to compare the values for the comparison of basic character among amines, among bases rather. So it is pKb. Just like pH, we know pH is negative logarithm of H plus concentration. So similarly pKb is negative logarithm of Kb. Fine. So as negative is there, fine. So if Kb for any base is higher, it is basicity is less. It will be a weaker base if Kb is higher. So lower the value of pKb, more is the basic strength of the base. Fine. Okay. Now let's continue further. Let's compare now the basic character of certain amines within their classification as well as with ammonia. Fine. So we have here, number one is comparison of basic strength among amines. So in that, first we will compare, rather it's a question that amines are more basic than ammonia. So we know this. Let's deal with this question. Usually it comes in exam. I have taken one primary amine. You can also take secondary or tertiary for this question. Fine. Here we have nitrogen, NH3, we have ammonia. So you see both are basic due to presence of lone pair of them. Fine. So more the electron density on nitrogen, more easily it will accept a proton and more will be its basic strength. Fine. And we know in the case of amines we have a R group which is electron donating group or electron releasing group. So as a result of this, electron density on nitrogen is higher. So it have more tendency to accept protons, so it will be a stronger base. But no such effect is present in ammonia, no R group is there. Therefore here we have electron density is less concentrated on nitrogen. Fine. So protons are less attracted. Moreover, this is one point of view. You have answered the question. Now another, if suppose H positive has to attack on these two, it will prefer this more electron density, this reaction, this step will be fast, right? So like that. Let's see if after attack of H plus what is formed here. We have here this ion is formed, and in this case we have ammonium ion formed. Fine. So we can also explain anything, order of reactivity. Whenever we explain, we can explain in terms of stability of the product form. In both the cases same step is taken, right? So this ion 1 is formed here, here ion 2 is formed. Let's compare their stability. Nitrogen have a problem here. Nitrogen is electron deficient due to positive charge. Same is the situation here. But here you have one R group which can increase the electron density around nitrogen and can give some relief to nitrogen from the electron deficiency. So this is more stable as compared to this one. Fine, this is more stable. So something more stable will be easily formed. You know this basic. So that means this step will be fast because something formed which is more stable. We usually say more stable, but actually we should say this is less unstable. Less unstable, because this is iron, this is also ions. Ions are unstable. So we can say it is less unstable, it is more unstable, right? But to understand in a simple language, we use the term it is more stable, it is less stable. So this is how we can explain one R group in primary. If two R groups, they have more effect. 3 R group, they have more effect. So all, remember one thing, primary, secondary and tertiary, all amines are more basic than ammonia. Fine. So this is comparison of amines with ammonia. First comparison, very important question. Now secondly, now we will classify the classification of amines, that is primary, secondary, tertiary. We will compare them. So we have here two things. If there is no water or no aqueous medium. Fine. Let's talk reaction taking place in gaseous phase. If reaction taking place in gaseous phase, no water is present, right? So in that case, let's compare the order of basic nature here. So this is your primary amines. This is secondary amines and tertiary amines. Fine. Just like we have discussed in the last case, availability of